So we have an example here that if a lift accelerates upward at a certain rate, a spring balance indicates a weight to have a mass of 10 kilograms. And see, if the lift is accelerated downward at twice the rate, the mass appears to be 7. Find the upward acceleration in the lift and hence the mass of the body. So I can maybe begin by saying, let A be the upward acceleration. Then, please don't forget some of our important points we mentioned. One was that when you weigh yourself, when you're in a lift, the weight you get is equivalent to your normal reaction, okay? The weight you get when you are in a lift is what is equal to normal reaction. And that will tell us that this one here will be our normal reaction. But we also said as well that when a body is moving up, it will appear more heavier than the actual weight of the body. And if the body is moving down, it will appear like it has lost weight than the actual weight of the body. So that means that if the body is moving up and it appears like it is having 10, that means in reality it is less than 10. And the thing, if it is moving downward, it's just 7. We said if a body is moving down, it loses some weight. That means that it is not just 7. It is bigger than 7. It is just because for a downward motion, the body appears to have lost some weight. So if we are looking at downward motion, upward motion, we shall say using our normal reaction equaling to what? mg plus ma. If you can still remember, if a body is moving down, upward, the normal reaction will be the sum of those two. And what is the normal reaction? They said the weight, the mass will appear as this. So convert it to weight, we shall say 10g is equaling to m into g plus a. Okay? And then I can call this an equation 1. And then I can also say, for case 2, we are looking at downward motion. If it is downward motion, we say we shall use R equaling to mg minus ma. If you can still remember that for downward motion, we subtract. And they say the weight appears to be 7g. That means 7 kilograms, kg. And that means that if you convert into weight, it will be 7g equaling to m here into, that's when I can say mg minus m into twice a. Because they said if it is moving downward at acceleration twice the first one, so that means I should say that. So this will end to 7g equaling to m into g minus twice a. This one can be my equation 2. And then I can say dividing equation 1, or I can say dividing equation 1 to equation 2, or dividing equation 1 by 2, we shall say 10g out of 7g should be equal to m into g plus a out of m into g minus a twice a. This and that will leave us, and then we can now decide to cross multiply. Is that okay? So tell that this one will become 10g. Okay? Or I can work step by step for you here so that I can follow. 10 into g minus twice a equaling to 7 into g plus a. So I can now open up and say this is 10g minus 20a, okay, is equaling to 7g plus 7a. So if this goes the other side, we shall have 17, that will be 3g will be equaling to 27a. We shall divide that one by 27, divide by 27. So that means my a is 3 times g, which is 9.8 out of 20. So what is my a in that case? You can pick your calculator and say you have 3 times 9.8 divided by 27. That is 1.00. That is 1.08889 meters per second squared. And that is the acceleration that you want. And now we are saying that hence also get for us the mass. Using this value, can you get the mass? So you can say from equation 1, I can say mass equaling to 10g out of g plus a. Is that it? Can we do like that? There are very many ways of dealing with it. So that's when I make m the subject from here. 10g divided by g plus a. And then my m will be equaling to 10g out of g plus a. What is my a? My a, I can substitute this value of that, or 3g out of 27. Okay? You can now simplify from here. 10g out of, what is LCM here? That is 27, and that is 27g plus 3g. So my m equaling to 10 times, okay, 27 out of 30g. And my m here will be equaling to, I can reduce this once, this 3, and then that will be equaling to 9 kg. So therefore, the mass of the body is 9 kilogram. You can also conclude for the acceleration and say, therefore, the upward acceleration is 1.0889 meters per second square. So that would actually be our solution to this kind of problem. Thank you.